the ability to use online processing power rather than your own poor little laptop to open up point clouds or open up big virtual tours, I think that's the biggest game changer. And I can mention names, but there's probably not much point. You can just Google all that stuff if you really want. But yeah, the ability to view online portals of your data and the model together is probably the most powerful and the biggest game changer, because it becomes evident to everyone that what's being constructed either is or isn't accurate. And so then the ability to move all of that information into an online portal for the asset owner to use, therefore becomes an immediate benefit to everyone.
Hi, Michael. Welcome to the Digital Construction Podcast. How are you today?
Yeah, I'm good, Andrea. Good to see you. It's been a while.
It's been a while, yeah. So today we're talking about reality capture with Michael Alder. Michael has a lot of experience in this space. He has been working for longer than 20 years, almost 22 years at Arup, and he's the regional reality capture leader at the moment, but he has been working in this space for a long, long time on many projects.
You're making me sound really, really old now. Thank you.
Yeah, maybe actually very good, because you are, Michael. I know that you are a point of reference in that. And also, something very cool about Michael is that in 2014, he initiated the move to the 3D point cloud scanning in the Melbourne office for Arup. So you've been playing this game for a while now.
Playing, I like that. It's very
yeah. Okay, Michael. So to get started, just a couple of icebreakers. If you could take a road trip anywhere in the world, where would you go, and what's your must-have travel snack?
Well, of course, it has to do something with riding. Okay, 'cause,
nice.
I love riding, and there's a ride here in Melbourne called the Melbourne Roubaix, which is based on riding on cobblestones. So if I was going to go anywhere, take some riding mates, take an old steel road bike and ride the Paris-Roubaix cobblestones. And
nice.
it's hardcore, but it makes me feel more like a genuine rider, you see. It's
nice.
And of course, if you're riding an old bike, you have to have coffee. So it's all about.
Oh yeah, of course. Yeah, you're showing to everybody you come from Melbourne, my friend.
Yeah. Well, and if you're in France, maybe we'd have to have like a striped top and a baguette shoved down there.
Oh yeah. That's always good. That's always good.
That's visualizing. The French music playing in the background and that sort of stuff.
Very romantic. Very romantic. Very good.
Yeah.
And if you could have any superpowers that to make a construction project go perfectly, what would it be? And it's this tough one.
I think I'd have a big P on my shirt, because it would say I'd be the planning superhero. It's all about planning. It doesn't matter. It doesn't seem to matter how much you attempt to plan and be proactive. It feels like everyone needs to be on the same page. The client, the different teams. There's so many different parties involved in any kind of construction. Building, infrastructure, whatever. It's that involvement of the client right from the beginning, and then the entire team, and having that all brought together and all actually understanding what each other's saying. It is such a different language. But, trying to actually get that communication happening. Right through to the people who are going to manage the building, right from the visionary at the start with the architectural team. So it's just trying to get that communication and planning going on.
Yeah, this seems to be a recurring theme when I ask this question, because you have so many people with so many different skills, but orchestrating everything perfectly is probably one of the challenges of this industry.
And I think the ability to interpret the sales pitch of the software companies and interpret that into a realistic expectation, because it's not the software, it's the people on the journey and how they use it for the end. Everyone wants this sort of digital asset deliverable, and we all know it's possible, but it happens a lot less than it really should.
Yeah, definitely.
Or, there's always this little, but it's all going well, but then this happened, or this person, or this, it's so many difficulties along the way.
Yeah, we've been in this place. I understand. I understand. Okay, so just to start, can you start telling us a bit about your career journey and what led you to work in the construction BIM reality capture space, and
Sure.
And if you can share some of the key projects you've been involved in.
I guess it all began in 1992. Yes, I'm that old, when I finished my industrial design degree. So I'm more artistic than engineering, I guess, in the sense that I got into industrial design through an art folio. There was two types of people. There was the sort of engineering maths, and then there was the artistic, and I was more the artistic side. So anyway, I finished my industrial design degree in 92, and nothing was available. There was just no jobs at all. But my first job was doing manual drafting, building services. Over time, because I'd used CAD, AutoCAD version 10 and 11, I'd actually done some 3D in that. I brought CAD into my first workplace. And so I sort of ended up bringing that into Lincoln Scott, which was my first sort of large consultancy. Started off drafting there, CAD 2D drafting. Then I wanted to do 3D. I said, I want to get back into 3D. And at the time, that was not something Lincoln Scott was doing, but Arup was. And I moved to Arup in 2003, believe it or not. So key projects, he said, and a couple of the key ones were the Alfred Intensive Care Unit, 2004, and also the Synchrotron project. Quite intense coordination projects, and we drew them in 2D, but then I also modelled them in 3D just to check the coordination. And I realised very quickly that it's actually quicker to model than it is to draw, and actually draw sections everywhere and do little sketches. And anyway, so that was sort of a couple of key projects back in the early days. But then eventually Revit came along. So between 2007 2009, I was part of the team that introduced Revit and that whole suite of tools. That was a massive change. Coloured drawings, believe it or not. But it wasn't until 2013 I had my first experience with laser scanning. It wasn't me doing it, but we were working with an architect who had actually had some existing building scanned, and we're actually looking at the squareness of the stairwell because it was a heritage building. And then I started working with Nathan Lyon from Investor on a project to do a chiller replacement, and 120 Collins Street. And so because I'd seen laser scanning, I had some done for that project, and that turned into a whole workflow of existing scan to BIM, adding asset data, pulling that through to the designer. We weren't the designer. I was really just being a digital advisor at that stage. And then even the post-install, post-handover, as-built validation side of stuff was all part of that little one chiller being replaced. And then I look back on that and said, even that workflow that we developed back then is still valid now, but we're applying it over much bigger projects on a much bigger scale. But that thinking is key. Existing conditions that are accurate, using that to produce the design drawings, checking back against the original scan, handing that over with asset data, as-built checking. The project workflow has really not changed too much from that, but it's scaled up. That's a very long introduction. I'm sorry.
No, it's very good. You show your career has evolved over time, and it's exciting to see how you've seen the transition from really pen and paper to reality capture. And yeah, this is very exciting. And today we're talking about reality capture. So just to make an introduction and explain to those people that are not as familiar about what reality capture is, can you explain to us what reality capture and 3D laser scanning are, and how do they work?
It's reality capture is a very broad term, and it has to be broad because it covers so many different technologies. So if you think of it as a sweep from very simple image capture, photogrammetry, 360 photo capture, and then over to laser scanning, it's like a broad brush that captures all of those things. So photogrammetry can be a whole bunch of individual images which are then brought together to form an overall image, which could be a tile on the face of the Earth, or it could be around an object, which then turns into a mesh, or it can be a 360 photo series of 360 photo images. And the most common way to explain that, apologies for the birds in the background, we've got some cockatiels.
Nice.
Every time someone walks past the front of the house, they like telling us about it. So everyone knows Google Earth. So you can sort of move from image to image and then look around. That idea of that 360 photo image is exactly what I'm saying with that virtual tour. And then if we move into laser scanning, if we can have static, we can have mobile, we can have all sorts of different ways of sending out a laser and receiving it, and then having a point on a surface. That's its most powerful when you combine that laser scanning technology with a 360 image, because it colorizes the laser scan as well as giving you a measurable image that you can navigate around and look at. Really important to understand that I'm not a surveyor. Okay, I'm an enthusiast, and knowing all of the really, really technical parts of surveying is not my thing. And part of that, which will come out later, I think, in the whole discussion, is where do I hand over to someone else? When do I know that our skills internally are not up to scratch? But how do we work with the higher end survey grade type of scanning all the way through to a basic photogrammetry capture, either from a drone or just from your phone? Can't believe I made that rhyme. But that's trying to be broad, but not everything is laser scanning. Not everything is, 360 images, but it's all related. And what's really nice is the ability to think of the right application of technology to the right application on site, depending on the need.
Yeah, you're right, because sometimes you have just images, sometimes you have point cloud, so you can, it depends if you need to take measurements, if you care about the quality of what things look like, maybe it's also... But
even that question about measurements, how accurate do you need that measurement to be? It's that whole question. Maybe we just want to have a look at what's there and the condition of that existing object, or maybe we need to take sub-millimeter measurements. What's the purpose of what we're doing? And that really sets the path to which technology is most applicable.
Yeah, very good. Thank you. And as we said, like, you've seen the full process and how things have changed from pen and paper to reality capture. From your point of view, how have these technologies changed the way we approach engineering workflows? Like, how has that changed over time, before and after these technologies?
Well, I've done it myself many times as a draftsman, to go out into the field to actually physically hand measure. Never forget doing a plenum. Once had to measure up a plenum, do a sketch myself on site, then draw it up as the existing conditions. It took me most of the day to do it. I actually ended up getting a scan of the same plenum done later, and I couldn't believe how badly I'd done it. Like, it took half the time and it was twice as accurate. And I think that physical hand measure combined with a whole bunch of photos on your phone, bang, 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 or a hand markup with a couple of key measurements. The problem with that is that there's very little context to what you're doing. Physically hand measuring something is very hard to do properly over a large scale, because you tend to have small incremental measurement errors which all add up to a big error. If I go to site and take 50 photos around the place, it's very hard, if you're someone who has not been to site, to actually look at those photos. First of all, find the folder that they've been dumped in, and then work out, I think that's looking at that, because in the corner I can see an exit sign, and hang on, no, that's a different floor. It's the context and the rapidity of the current technology, like how fast I can get out and get back to the office, how quickly I can share that with everyone. That's the real big difference. Previously, you'd be having multiple trips out to site by multiple people, all taking their own photos, all throwing it in a folder, and all trying to look at different things for different purposes. The mechanical engineer, electrical engineer, the architect, structural engineer, they all have different things that they want to look at. But when you have it captured in a single portal, either a virtual tour or a laser scanning capture, everyone can look at the same data from different points of view and get different things out of it. But because you've got the whole area, everyone can look at it and walk around it. It's actually a lot safer because you only got one person visiting site. Not 50.
Yeah, that's true. Yeah, that's true. We didn't consider the safety aspects of reality capture. The fact that you're only sending one person rather than multiple people over multiple site visits.
And it might be a remote or hard to get to place as well. It might be dangerous. It might be in a confined space. It might be just unpleasant to be there. It might be hot, might be smelly. Who knows? But by doing it once, it's also a point in time. And I'm probably going way past just this main question, but you can go and do multiple site visits and compare over time how something's changed in its condition, or erosion, all of those sorts of things, rust, facades, all this sort of stuff, just because of the very high quality of the images that we can capture.
Yeah, no, it's incredible. And yeah, very good point, the one around the context and being able to understand the mutual relationships between images or scans, so you can actually understand where you are, where that, for example, photo has been taken from, and it eliminates all of the guesswork, and everybody is aligned looking at the same thing. It's actually an improvement of what the reality looks like, because if I, as an individual, were standing inside a room, it will still be harder for me to measure the distance of different things. I will have to go there and measure, while if I'm inside a virtual model, I can actually measure things very, very quickly, even if I'm not there. So that's a massive improvement, I think.
Yeah. No, it is. It's a high, and I think what I've seen in the last 10 years is that since it used to be a very bespoke kind of technology, whereas now I think most project managers, most engineers and consultants and builders all sort of know what it is. Most people, when they go and book a house to go and stay in, they like doing a virtual tour around that house. It's sort of normal now. It's changed a lot in 10 years, I think. It's a lot more common.
Nice. Yeah, okay, Michael. So we have touched on what it is and how the reality capture has changed the workflows. But let's talk about how do we actually capture data. So we are collecting high quality data using laser scanner, but also other tools. So what are the key tools and technology that we are using to acquire accurate site data at the moment?
Yeah, if you have the right equipment, you can actually go a long way down the path to doing a lot of accurate geolocation of the scan data. So freely available is permanent survey markers, PSMs. They're normally a site-based permanent marker that you'll find either in the pavement or on a corner. Those are all available on websites to actually look at. Here's an actual coordinate. So often what we'll do, because we've got an antenna as well to take up GPS, is align our scan that we're doing in the area to the nearest permanent survey marker, add in some GPS coordinate points, and then that gives us the real coordinates that we're able to use. Now, I've got an advantage, even though I'm not a surveyor. We do have qualified surveyors within Arup, so I can always acquire the data, get it checked by someone who has more experience and qualifications than me, or I can hand those scans over to a surveyor if it needs to be validated. But as a starting point, we can go straight in there and grab points using a GPS antenna. And so in terms of key technologies, that becomes the starting point, but then having a high quality laser scanner that's static. So in terms of taking position by position scans, typically we're using a mixture of different ones. We've got a Trimble X7, Faro M70. We've got quite a number of these different units now that we share around the different offices. So having a good antenna, or a way of finding survey markers, a way of using the actual scanner on site, they're the main tools. But then you need a way to process it as well. So you need to actually be able to take the data that's raw, register the data together, and then align it to the survey marks that you've picked up. So they're the sort of key, there's sort of three phases of the process to me. There's the capture, there's the registration, and then there's the production. So how do you align that to a model? How do you align that to the coordinates? And then how do you publish it so that others can actually look at it? Because it's no good having it in its native format. It needs to be published into a way that can be used in a model or viewed online. So it's, the three sort of phases. So the key is really having the right tools in the capture stage, in the registration phase, and then in the publishing phase.
And I guess this tool keep on evolving with technology, new software, new scanners. So you always need to stay updated.
Well, it's not just, like I said a little while ago, it's not just the tripod-based scanning. Now there's a whole bunch of different types of mobile scanning: handheld mobile, vehicle-based mobile. You can get ones on the front of a train. You can get them in a aircraft-based, drone-based. There's more and more on the market all the time, and typically they're becoming easier to use. And that's the aim, is so that they're faster, so that capture phase can be done faster and spend less time on site. Get the processing done faster. Get it handed over to the team or the external client.
And I'm sure during this process there will be challenges when you try to collect data. What are the most common challenges, and how do you overcome them? I
think getting access to site would be a big one. Are there restrictions? Are there timeframes that you really need to overcome? Is it a restricted site? Is it a site with security challenges in terms of what you're actually scanning? How that data is going to be used afterwards. Are we going to capture people's faces? Are we going to capture information within that site that's sensitive? So it's about planning that access to the site so that you're not spending too much time capturing irrelevant objects. So being really focused on the actual challenge, not just scanning because it's cool. Oh, I really want to scan the front of this plane because it looks really cool when I scan it. No. It's the stairwell, or it's the pipe connection, or it's the equipment. It's being focused about that. And I think that's one of the advantages of having an in-house scanning team, is that you have direct access to the person who's going to be using that scan for that engineering application, so that you know exactly what the focus and the purpose of that scan is going to be, and therefore it can be more efficient and done in a way that's more focused. I think one of the biggest challenges of everything is obstructions. Scanning is only ever done in a straight line. The reason you need to take multiple scans is to get around obstacles. Everyone always wants to know, can you scan through like an X-ray? No, you can't. There are specialist in-ground scanning to scan through Earth, but that's very specialist. But scanning through a ceiling, unless you have a ceiling tile you can pull down, or you can cut a hole in the ceiling in the right spots, the biggest obstruction is literally an obstruction, because you can't scan through it. And then trying to join them together. So if I can get into the ceiling and scan, and I can scan below it, how do I make the scans see each other so I can actually join them together? So if I go through an access panel, I want to scan below the access panel, in the access panel, and above the access panel, so I can sort of get views. And all of this takes time. So if I've got let's say a house with lots of different doors, I need to scan either side of the door, sometimes in the doorway, so I get good coverage. And that's planning. That's really key, because I might say, oh, this will take me half a day. And then I realise I'm on site, oh no, there's so many doors, so many obstructions. If people are walking around while you're scanning as well, that can be a problem as well, because it causes smudges or shadows, which then might need to be cut out later. So there's lots of little subtle things.
Yeah, it looks like the site set preparation is probably the most important part in this process.
Yeah, absolutely. And having as much information about the site before you visit it as well. I mean, even I remember doing a floor flatness survey for a new piece of equipment coming in for a hospital, and oh no, it's all empty, it's all fine. And then I arrive, and then there's just boxes everywhere. I spent half my time moving boxes out of the way so I could actually scan the slab, so I could then actually get a good coverage and actually see how much it's sloping, or has it got divots in it. That's like very fine sort of stuff. But unless you plan it.
It looks like you need it looks like you need a lot of coordination with the clients to make sure that Absolutely. The site is ready. Do you go there and visit the site before you actually do the scan, or do you just tell them what to do? Do you have a checklist? Yeah,
it depends. It's really about talking. Do you need a security escort, for example? Sometimes you'll have someone with you. Do you need extra access equipment like platforms to get up? It might be a double height space, so you might need an access lift or a cherry picker to get up high. So it's all of that sort of planning and communication with the person owning the site. Or it might be a construction site. Do you need to have particular access to, white cards? Could be a rail corridor. You'll need special training and sign off that you're allowed to actually enter that site.
Very good. So we talk about how we capture data, but we also know that reality capture is used to verify construction during engineering projects. From your point of view, how is reality capture used to verify processes and accuracy during the construction or even during the engineering phases?
Yeah. Existing conditions capture is usually the beginning of a project. Typically, there's a lack of documentation. Typically, any drawings might be 10, 15, 20, 30 years old, and the site has changed multiple times since those drawings. So everyone knows that those drawings are not accurate. They're still important, but they don't have the current conditions. So doing that existing scan and then modelling, or at least measurement from that existing condition scan, becomes critical. And so then during the construction, we've often done, sort of periodic checking on the installation. So we do BIM construction management, but if it's not being installed the way it's been coordinated, then everything's a bit useless. So doing spot checks on that installation progress and then comparing it back to the coordination, BIM coordination process during construction can actually really help stop wasting time, because we can continue to coordinate, but we're not coordinating with the actual current building. And then, of course, as the as-built documents get put together, a scan is often an easy way to just do a final run through the site.
And how do you check if the as-built version actually matches what was modeled, what was designed?
Mm-hmm.
Because I guess you will have a model, and then you will have a construction site that is real and it's there. How do you check that they actually match?
Couple of different ways to do that. One's just visual. So you can just look in that actual model that is produced in the as-built drawings, just have a series of check views, at different heights, different section views, just do a visual check. That's the fastest way. But there are softwares as well which can do a scan versus model check to an actual tolerance. So you can do a tolerance check and then get a report of every element that doesn't meet the tolerance, so that you can go that sort of full report, or can do a really fast check through the model. And it's key, obviously, to line the scan up to the model, because then what you do is you send that scan out to the party who needs to produce the as-built, and they then need to make sure that their as-built conforms to the existing conditions. And that's why periodic scanning, if you've got multiple layers of services, for example, if you scan just at the end, you just get the outer edges of that. Whereas if you can scan during the different layering, then you have much more chance of capturing everything, especially some of the smaller services that might be hidden. Because we talked about obstructions before. Sorry, I interrupted you.
No. I was just going to make a joke and say that it looks like a clash detection where you want 100% clashes. Yeah. Because it needs to match, right?
Yeah. 100%. 100%. And look, nothing's ever exact when it's installed because of the different, maybe that to get something installed to keep the program, something had to be installed before something else.
Yeah.
But how often does that come back through into the coordination construction?
Yeah, sometimes I've seen pipes that were supposed to be, like when we model in Revit, we model perfectly straight lines, but then on site, nobody can actually build a perfectly straight line. So all of those pipes end up having a slope, even if they shouldn't, but it's a very small slope. So it's very interesting. I imagine how this can also improve the construction process, reducing rework, because imagine what could possibly happen if we build something that is not exactly what's supposed to look like, and then we have to rectify that. How do you think this technology can help reducing work and improve the overall efficiency of a project?
It's about being timely in the application of the technology. So maybe after the base buildings, a level's been done, where are the penetrations? Are the penetrations themselves in the right place? If we start with that, then all of a sudden, we've got the real penetration location. Okay, how's that going to impact the proposed locations? Maybe we couldn't put the penetrations where they were because of some other reason, or maybe the design was ahead of where those penetrations were going to be. Instead of then sending all of the components to site to be installed and then having to get stuff redone, we need to remake these connections. By having a heads up about those things will always improve the efficiency. But as long as it's done in a timely way, it's those tight coordination issues, or it's part of getting prefabricated stuff done. Because we know we've got real confidence in the site conditions, prefabrication can be a lot more efficient because there's no question marks. It's all going to fit because the site conditions are 100% correct. It's that kind of thing. Clear existing conditions, periodic checking for installed location during the whole process, and then it gives confidence to the asset owner that what's actually there is what's actually there. And a way for them to actually go back and walk through it, even when they're not on site. Or even if they are on site, it's more efficient to walk through the site virtually than physically, especially if the sites are half being constructed. It's just
exactly. Yeah, and we just talked about this, like how we handle the entire construction process, but at some point the construction, the building or the infrastructure will be completed. At that point, how do you think laser scanning can help produce accurate as-built documentation at the end of the project?
Well, there's just no question that it helps because it's 100%. Well, if it's been done correctly, there will be no hidden areas. Everything that's behind a wall, behind a bulkhead, even the potential to scan reinforcement within a slab before a concrete is poured, it actually augments the documentation. The documentation is only ever going to be as good as the accuracy of the as-built reflecting the construction. So the more of the reality capture deliverable you can incorporate into the process, the more accurate the as-built will be. And I really like the idea of, before any walls are put up, you've got all of the hydraulics in the wall, you've got all of the conduits, even a lot of underfloor, raised floor services, for example. Scanning all of that before it all gets covered up makes the documentation so much better, because if I'm going to come back and find something to repair something or to add to it, I can find that junction box, I can find that valve, I can find it because I know exactly where it is, not just where it was intended to be. So yeah, and I'm talking mostly buildings here, but it matters for anything, any kind of industrial, any kind of in-ground services. For example, you might have an entire precinct where you've got incoming in-ground services. Knowing exactly where they are, how deep they are, can obviously cause a lot of hassles if you don't know where they are. You might start digging up in one area and you realise, it's actually over here. And maybe someone knows where that is, but maybe it's 5 years ago. Who knows? So the more of that kind of data you've got, obviously, the better you're at, better position you're at the end of a project.
And this could be very useful for owners and facility managers. At some point, you will have to hand over this model. So what do you normally do? You just give the model to them? Do you sometimes keep on maintaining the models? How does it work?
Some asset owners will hold on to the models. Some will even know what to do with them, but typically it's not common. I'm not saying it doesn't happen. Of course it happens, but I don't think many asset owners really know what to do with the data once they've got it. Do they keep it in a Revit file that eventually is going to be out of date and need 5 upgrades to get back to where it was? It's all of those sorts of issues. Once the asset owner holds on to that, do they have the skills internally to maintain those models? Do they have the skills to keep viewing any reality capture that was done during the process? Unless it was set up at the beginning of the project with an understanding to hand it over in a way that they can actually view it and keep accessing it, then I think it eventually just comes like any other kind of documentation. It can just get out of date, and also potentially that the models won't be accessible after a certain amount of time. If I try and find a Revit model from 10 years ago and use it, you can tell me how easy that is.
Yeah.
it's problematic. There are workarounds, but it's not easily accessible. So unless that's sort of built into the program to have a usable digital asset management plan, and actually have the people at the receiving end actually able to do it and even understand what they have, then I think then there's a big opportunity, or there's a big chance that opportunity will be lost during the handover. So it's one of those things where I think there's a huge opportunity in the market at the moment for that real handover to happen. I think that's where, if you look at the development of BIM over the last 10, 15 years, we had the enthusiasts and the architects and the engineers. Now it's the builders and the construction team. They're all on board, as far as I can tell. It's now it's the asset owners' turn. And of course, you've got examples of asset owners taking that on board, and every day you hear about more and more teams, infrastructure teams, all using the information. But I think there's still a big amount of asset owners who know that cognitively, yes, we need to be doing something with this, but we don't have the skills or the time or the ability to get the best out of it. And they might know where the models are. They might know how to use particular softwares, but is it part of everyday reality? I think more often not than it is. Does that make sense?
Yeah, it makes sense. And do you know any specific software or platform that you recommend? Like we don't have any relationships with vendors, by the way. Just any software or platform you think could improve this process.
Look, my experience is mostly with, I guess, any kind of, for our processing, we use Trimble RealWorks, but there's Leica products. There's even free products like, for viewers, Recap. So you've got Autodesk Recap. You've got, most of the softwares that we use to model with. You can look at reality capture, data, laser scanning. But I guess the main game changer, I think, really has been the development of online portals where you can do virtual tours, where you can look at laser scanning, where you can extract information or even just do measurement. So, there's a whole bunch of different software vendors, but the ability to use online processing power rather than your own poor little laptop to open up point clouds or open up big virtual tours, I think that's the biggest game changer. And I can mention names, but there's probably not much point. You can just Google all that stuff if you really want. But yeah, the ability to view online portals of your data and the model together is probably the most powerful and the biggest game changer, because it becomes evident to everyone that what's being constructed either is or isn't accurate. And so then the ability to move all of that information into an online portal for the asset owner to use, therefore becomes an immediate benefit to everyone involved in the ongoing asset management of that, that data, because it's also linked with asset information as well. So the best portals are the ones where you can pull through the information of the model asset information and the reality capture all together in one portal. And I think that's where the real advantage has been, and the real development even in the last few years. More and more of these types of portals are coming to the fore, and they're not just used for communication before and during the actual project, but afterwards. I think they're getting more and more traction because of the ease and the lack of skill that you need to navigate your way around them. You don't need to be a Revit user. You don't need to be a RealWorks or a Leica reality capture expert. You don't need to know all of that stuff. You've got something that can actually bring it together in a single portal.
You don't need to install new software. You don't need to figure out what's the minimum requirements of your laptop to make sure that you can actually view that file. You don't need to think about all of the different file formats. Everything is combined into a single web port. So use Google Chrome, basically, or Firefox, or whichever browser you like.
Yeah. And I remember the very first time I tried to hand over a scan to a client, I had to send them a hard drive, and I had to send them an executable file for them to install the software to view what was on that hard drive. And it didn't take long for me to realize that not everyone has got admin rights on their own computer. That became the biggest problem. So then the search was on, how do I upload all of this data to something that I can then give someone secure access to so they can view and look at what they've got. And now there's a number of software portals that do that. And that's probably the biggest game changer.
And even the opportunity that you can upload a file now, and I always get the latest version. I just need to go on the portal, and I'm sure that I'm getting the latest version. That's also something that it feels obvious. Like it feels like obvious if we talk about this right now, but it wasn't there a few years ago. So
no, it's become easier and easier, and even the portals that we use, I'm able to combine my laser scanning with a subcontractor's laser scanning. So we do projects where we might do a certain portion of that scan, but then we get an external supplier to give us a drone capture over the top, or an underwater scan as well. And we can combine all of these different ones. I can use those portals to gather that data to myself rather than waiting for the post or a courier to arrive with the hard drive. These become communication portals as well, where I can give, I can do a scan of your house. I can then upload the scan to you up to a portal. You only have access to it, but you can then download a crop of just what you need for your upgrade. So it gives you control over what data you pull down and how you want to use it. So it makes it a lot more easy and smooth transition. And it means I just need to set up an upload going, and I can walk away. I don't have to wait to copy it to a hard drive and then find a courier. Oh no, it's a Friday night, quick,
Yeah, definitely. And speaking about projects, is there any specific projects that you can share with us where reality capture played a critical role? And in general, speaking about industries, we have infrastructure, commercial buildings. Like where do you see this technology to be more impactful?
I've tried to think of a few different examples across different industries. I've got a really nice example where I've done a number of scans at Sugar Australia. So industrial, but not just industrial, heritage. So it's actually heritage listed working industrial site. So even I remember doing a scan in the sugar store, and the actual timber structure is heritage listed. So doing a scan in there to understand the timber structure that's over 100 years old. And some of the building was damaged, so we had to do some scans because some of the drawings were lost, and some of the equipment is of such a scale that it needed to be captured for replacement purposes, but there was literally no documentation. And even to the point where we needed to scan the path that this large equipment needed to get out of the building so they can plan the replacement. That's industrial. Look, plant rooms, I think, are one of the all-time great examples. So 120 Collins Street, level 52 chiller replacement. That's my OG from 2014. And just just to know that we couldn't use 30-year-old drawings. We use them to know, okay, so that's the internal diameter of that pipe underneath the insulation, but knowing exactly where that pipe is to cut it and to reconnect it. Any kind of end-of-life equipment replacement, critical. Recently, we're part of a tram corridor upgrade, so we didn't do the scanning. That was a mobile scan that was done on top of a van. But we provided the portal for all of those scans to be uploaded to, and then we did some feature extraction from that. So we downloaded the scan, pulled out the critical features for tram stop upgrades. So there's that kind of example where large scale, I think over a couple of kilometres worth of scanning was done, but it allowed us to get really fast access to the data for us to get our engineering and design going faster. We did a heritage, there's a pipe bridge in Barwon, part of Barwon Water, and it goes over a river. So we did scanning underneath it. We had a drone do a scan over the top. We combined that together for us to do some remedial design works. So heritage, large infrastructure kind of works, also condition assessment built into that as well. And then probably the largest project we've been doing work on over the last 5 years would be Melbourne Airport. So a lot of work at Melbourne Airport. It's constantly having upgrade works, expansion works being done. So we've done a lot of scan to BIM existing conditions where we'll do the modelling and either hand it over to another team or it'll be part of our team that does the works on that. So yeah, large, small, one single plant room or part of an entire precinct in an airport.
Lots of different applications, yeah.
So many. And I'm only just touching on it. You've got rail scans of the entire city loop. Where does the city loop sit underneath the building we're building?
Oh yeah.
That kind of stuff. So there's huge applications everywhere. And I've only just touched on a few of the examples that we've done.
Yeah, that's incredible. And this technology, like any other technologies, will have challenges and limitations. We already touched the challenges with preparing the sites and making sure that everything is ready. Nobody has left too many boxes, so you can actually do scan. You can do your work properly. But what are the biggest challenges that you see when you're trying to implement reality capture on projects? And I'm thinking about things like large data sets and file size. And how do you actually address them? How do you solve these problems?
I think when setting up a project that involves reality capture or laser scanning, it's what I said at the beginning, trying to really determine the end use and scope of the project. What's the real driving reason that we need to be doing what we're doing? We don't want to just scan it just for the fun of it, just because it's cool. We want to spend that time really efficiently just to get just what we need. But then at the same time, are there any other opportunities that can save time down the track? We might be doing one development, but if we capture some adjacent property, maybe that can save time later on for the scoping of future projects. But the biggest conversation I have usually is how much time is what we're proposing going to take, depending on the type of capture. Now, if I do a virtual tour, that might take about a quarter of the time that a full color laser scan of the same space will take. So it's determining, yes, I need accuracy. Am I checking how flat a floor is, sub-millimeter? Am I checking, the depth of a piece of steel in a bridge, because it's critical to then do some load calculations? Or am I just doing a condition assessment of a room because it's a piece of heritage architecture and we need to see, at this point of time, do we need to do any remedial works? It's that kind of scope and end use that becomes really critical. Does that make sense?
Yeah, it makes sense. So do you think that clients and or owners or facility managers should be aware of any specific limitations of this technology? Because, like, there is always this conflict and tensions between the expectations that people may have in their own head and what we are actually going to deliver. So what are the limitations that you think this technology has and people should be aware of?
Yeah, I think a couple of the main considerations are really the cost of outsourcing that kind of skill, or purchasing equipment and learning how to use it for your own purposes. So typically the higher the cost of the equipment means the higher the accuracy and the range. The actual, how far will that laser travel before I never see it again? Some of them do 70, 80, 90 meters. So they can actually capture some pretty amazing sites, but the cost will be potentially twice or three times, what you might call a run-of-the-mill laser scanner. If I'm going to capture a whole site, but I just want to use a little handheld 360 video camera, I can do it, and it might cost a few $100s. Or I can go around and spend days with a tripod-mounted scanner. As long as we're aware of the limitations and the cost associated with that limitation, and then the higher the cost, the higher the skill needed to use it and to then get the information and process it into a usable form. I think that's the main sort of balancing act. And then in terms of trying to keep on top of the changing technology, it has changed pretty rapidly in the last 10 years. And then I think you go back, like laser scanning's been around for a long time. If you look at the original laser scanners, they looked like they would bring something like a satellite down out of space. They look that big, like these huge vehicle mounted scanners that were, hundreds and hundreds of thousands of dollars. But the technology is smaller, it's faster, it's higher quality, but it's still pretty expensive. But I think the bigger challenge is more, once you've captured it, how do you use it? It's that sort of knowledge and the amount of technology and other softwares which are now tapping into that are really interesting but ever evolving. So that's a challenge to anyone who wants to be involved in this kind of tech.
Yeah, and speaking of evolution and future, where do you see reality capture evolving over the next, let's say, 5 to 10 years? Now it's hard to predict the future, but you've seen how the past has evolved. Where do you think all of this is going?
I think some of the coolest stuff I've seen recently is the ability for, and it had to come up somewhere, didn't it? But AI and machine learning to start having a real impact. We've talked a lot about machine learning, looking at things like automated condition assessment of, say, glazing. And this is one of the discussions we had a long time ago. But I'm seeing that actually now come to actually be used. The ability to teach a computer, all right, so what type of glazing crack is this? Now I'll give you 5,000 images. Now you can tell me how many of these are of a critical nature, how many of these, it's that kind of rapid assessment. I've seen some AI which can start identifying objects within a scan and segregating it. So I can have a huge scan of an industrial plant, and I can say, all right, find me all of the valves. It's not perfect yet, but it's actually pretty scary how fast it can find them and segregate them. So instead of me sort of trawling through the scan, oh, there's one, let's segregate that little one out, it actually can find them very quickly. And then you can start tagging those and linking asset data to them, and potentially linking that asset data to the drawing which shows that particular valve. So linking actual and asset ID to the scanned reality of the same piece of equipment. So it's that kind of integrated asset management, AI. I reckon that's where it's all going to be heading. Object recognition, where the image, it can read the actual asset ID.
Oh wow!
And then pull that in as a piece of known data. So it's that kind of stuff I think should become better and better, probably quicker than 5 years.
Yeah. Yeah, the technology of AI is also helping us. It's also helping another industry, like the physical one, that builds drones and robots, because now we are giving some level of intelligence to these devices. Do you see that technologies like drones and robots will be able to play a bigger role in space of data acquisition?
Yeah, absolutely. They already exist. We've already seen the little dog, with the scanner on it. All of that kind of technology it's already there, but it's really about how quickly does it trickle down into everyday use. Like already, mobile capture, vehicle mounted, that idea of the. You've probably seen examples of 360 video cameras on construction helmets doing daily walkthroughs of sites. More wearable stuff. All of these sorts of technology will become more common and more used. And the more people that see it, the more people that are interested in it, and that momentum just keeps building. And I think that all of these things just become more normal rather than being, it's that whole curve from this is really advanced and really cool to more normalized.
Business as usual. Yeah,
that's it. That's the word. And I think the overlay and ability to tailor and customize the AI will start taking out a lot of the manual effort in not just segregating scans, but identifying elements and tagging them within virtual tours, that kind of thing. Absolutely. Very exciting.
Thank you, Michael. So we are at the end of our episode. This was a great episode full of insights, and I'm very, very excited to share this with the audience.
Too kind.
Yeah. Just the last one. If people want to reach out to you, where they can find you?
In Melbourne, having
in Melbourne,
coffee.
Nice.
No, I'm obviously at Arup in Melbourne, and yeah, the what do you call it? I'm on LinkedIn. You'll see me there somewhere. All of that sort of stuff. I don't hide myself too much, so just we're up physically up the Docklands end. Is the Arup office now. But
nice.
Always happy to chat and talk reality capture. As you can see, I can talk on and talk on. I've probably gone longer than you wanted me to. So
No. This has been a great episode. Thank you, Michael.
No problem at all.
Thank you. Bye.